Hey guys, it's Tilsley again with your maths lesson for today. So it is Thursday today and we are going to be continuing our learning from this week where we've been looking at angles and now shapes, okay? So I'm going to try and have this lesson similar to yesterday's where I show you some slides first, okay, just to recap and rewind our learning. Is that my first slide? There we go. Okay, this is my first slide. And then we're going to go through the actual lesson for the day, okay? So, firstly, rewinding just back to yesterday's lesson, what do we mean by regular and irregular shape? Okay, so have a quick rewind. This shouldn't need to be brought from the back of your brain because really it was only from yesterday, so it's kind of just put on the side of your working bench. So just bring that to the front of your working bench again. Okay, and what does regular and irregular shape mean? Okay, so hopefully you've said about regular shapes. All have equal interior angles. Now I've made interior angles in bold, in red. Okay, that is because it's one of those tricky words that we need to know. It's key vocabulary for this week. Okay, an interior angle means the angle that is inside the shape. So for example, this angle here, if I can get a pencil now, I can't really use a pencil very well, but it's the angles that are inside the shape. For example, these angles. Okay, so interior angles where the two sides meet, the angle that makes. Okay, so a regular shape has equal interior angles, equal meaning the same. It also has equal length sides. Irregular shapes have different interior angles, so they might have two that are the same and then two that are different. Okay, they might have only one that's the same and two different. Okay, or they might all be completely different. They also have sides of differing lengths. That just means that the sides might be different lengths as well. So here you can see that actually not all of these are different to each other. These two are the same as each other, but they're not all the same. With these shapes, the sides are all the same, equal sides, okay, whereas these are differing lengths. All of them are differing lengths, okay, and making interior angles different as well. Okay, so we're going to be moving on and we're going to be focusing on just triangles for this lesson. Okay, so we've gone from irregular shapes, lots of different shapes, okay, different hexagonal shapes and triangular shapes. We're just going to focus on just the triangles today. So firstly, what can you tell me about these three triangles here? Okay, what can you tell me about them? It might be something to do with the sides, it might be something to do with the angles. What can you tell me about these shapes here? Okay, so I want you to pause the video here and just have a think about what you could tell me about these. Okay, so you might have said that this triangle has all equal sides. All of the sides are equal. All of the angles are equal. Okay, all of the interior angles are equal. I could use my maths knowledge from yesterday and talk about the fact that this triangle is a regular shape because all of the sides are equal, all of the angles are equal, therefore it's also a regular shape. Okay, all of them are equal. This shape, I could talk about the fact that the two sides are longer and it has one short side. Okay, I could talk about the angles being all acute. Okay, the angles are different. All the interior angles are different measurements. We have got an acute angle here, all are acute, but these two angles will be the same as each other, whereas this one is a lot smaller. And I've got this triangle here. Again, all of my interior angles are different. I've even got a right angle here in the corner. Okay, so one of my triangles has got a right angle, and again, all of my sides are completely different lengths. So I've gone from all the same to the same, none the same. Okay, does anybody know what these triangles are called? Okay, so these triangles, we have an equilateral triangle, which has three equal sides and interior angles that are below 90 degrees. So using that learning from Miss Noak on Monday and Tuesday, we've got an acute angle because their angles are below 90 degrees. An isosceles triangle has got two equal sides. Okay, an isosceles has two equal sides, and a scalene triangle, bear with me here, has no equal sides. Okay, And you'll notice that we've got a right angle on one of these, and then we've got, none of these have got an obtuse angle, but we could measure the triangles by angle as well. So this is what we're going to be looking at today. We're going to be looking at the words equilateral, isosceles, and scalene. These are 3 different types of triangle. Okay, this is where we're going to move on to our discover. So this is the bit where it is our turn. Okay, so we've got classifying triangles. That's what we're going to be doing today. We're going to be looking at these different triangles and classifying them, ordering them in a particular way. To classify means to sort, to order. So we've got Ambika and Lee have both folded a piece of paper up and they will cut those shapes. So I can see that Ambika has got a square piece of paper and she's going to cut it along the diagonal and she's going to make 2 triangles. I've got Lee, he's got a rectangular piece of paper. Again, he's cutting it from corner to corner in a diagonal, and he will also make 2 triangles. So what I want you to think about is, do you think that Ambika and Lee will both make the same shape? And what might be different? Okay, so have a think now, pause the video here. Do you think they will both make the same shape? What could be different? Okay, so what I'm going to do now, I'm going to share my screen. Look at that, seamless. I've got it already, not like yesterday. Okay, so what we've had a look at is this. So Ambika, her shape would make this kind of triangle. So yes, going back to that question yesterday, but we'll both make the same shape. They will both make a type of triangle. But the difference being the type of triangle that they've made. So when folded in half, a square along a diagonal, the square and the rectangular piece of paper will both create types of triangles. Okay. Now, both of these triangles have got a right angle. You can see here that in the corner, they have both got a right angle. Now, the square makes a triangle that has 2 equal sides and 2 equal angles. This is called an isosceles triangle. So this one, made from the square that Ambika made, has got 1 right angle and 2 equal acute angles. Therefore, this is an isosceles triangle. Then we've got the rectangle from Lee. He has made 3 unequal sides. So he's got 3 sides that are different to each other. He has got 3 angles that are different to each other. These 2 angles are both acute. They're both measured differently. This acute angle is a lot smaller than this one here. And we've also got a right angle in there as well. So this is called a scalene triangle. So we've got isosceles that has got 2 equal sides and 2 equal angles. We've got a scalene where everything is different. Okay, and then we've got the equilateral that everything is the same. So they are the 3 types of triangles that I want you to focus on today. Isosceles, scalene, equilateral. Okay, we're going to move on to our think together. This is similar to yesterday. Yesterday, the think together gave us some examples, okay, and all it wanted you to do was label them. Okay, remember this links to our independent work. So this is the our turn bit. This is where we're going to go through together, have a practice, and then you're going to move on to independent, which is completely by yourself. So I want you to, for question 1, just in your journal, your blue maths journal, can you write which one of these triangles is a scalene triangle? Have a think, have a remember about that kind of language. Remember a scalene, if we go back to the previous page. And oh, it's having a bit of a nightmare at the minute. Next page, next page. Oh, it doesn't like this page, does it? Well, let's just zoom out. Here we go. Goodness me. Technology, eh? So remember, a scalene triangle has no equal sides, no equal angles. An isosceles triangle has 2 equal sides, 2 equal angles. And so this question, which of these triangles is a scalene? Scalene have no equal sides, nothing the same. Now, it's given you a bit of a clue here. Remember, where there's a character that pops up with a speech bubble, that's kind of a bit of a clue. You could use a ruler to measure the sides. Okay, the measurement itself isn't important in this lesson because I don't really need you to measure the exact accurate length. The measurement will help you decide whether the sides are the same size or not. Okay, so which of these triangles has got completely different angles and sides? Okay. Pause the video here and just choose which one. Okay, hopefully you have decided that C is our scalene triangle. Each side is a different length. Each angle is a different measurement. Okay, so C is our scalene triangle. B, I think, is equilateral, and A will be isosceles, but we don't need to know that information. My question is, which one is the scalene? C is my scalene triangle. Okay. Following that, question 2 in your books, which of these isosceles triangles have 3 acute angles? Okay, so all of these are examples of isosceles triangles. Remember, isosceles meaning 2 sides and angles the same, one different. So all of these are examples of isosceles because they all have 2 sides the same, but one side different. The question is asking which of these have got 3 acute angles. So again, that learning from Miss Nope. Acute meaning smaller, less than 90 degrees, less than my right angle. It has to be less than. So which of these have 3, so all acute angles? Okay, I want you to just write the number 2 in your books and then write down the list of letters of which ones all have acute angles. Okay, so I can see that A has an acute angle because there are no angles that are bigger than a right angle in there. B is not does not have 3 acute angles. I can see that this side, this angle and this interior angle are both acute, whereas this one is obtuse. It is bigger than 90 degrees. Okay, C is also an isosceles triangle that has 3 acute angles because each interior angle is less than 90, less than that quarter turn. Whereas D is not does not have 3 acute angles because I can see that this angle here is an obtuse angle. It is bigger than my 90 degrees, bigger than my quarter turn. And E is also an isosceles triangle with 3 acute angles. Each interior angle is less than a quarter turn, less than 90 degrees. Okay, remember, don't worry if you do make a mistake, just fix it along with the video. It's absolutely fine. It's that memory of fixing it, that muscle memory, and that next time you come across this, that gets embedded in your brain. So when you do come across it and think, oh, I'm not sure whether it was this or this, actually, I remember now I had to fix it because I made a mistake. Okay, you sometimes fix the wrong, you remember the wrong thing and fix it, okay, rather than embedding the wrong answer in your head. Okay, it's better to go back and fix than not do anything with it at all. Okay, then it's the wrong answer that gets embedded, not the right one. Okay, right, so I'm not going to move on to the next thing together because I think it involves you having to draw something. So we're not going to do that one. What we are going to do instead is move straight on to your independent work. So again, with yesterday, I'll go through with you what the independent work looks like. Okay, this will be a worksheet available on a story for you. If you can print it out, great. If you can't, don't worry about it. Just copy it up as neatly as you can in your maths journals, okay, and just take a picture of that. Because everything that you're sending in is brilliant. We are able to offer feedback, and which is great. Okay, we can see exactly where we need to pitch the next level. Perfect. So what I'll do now is I'll try again and seamlessly share this one. Okay, so in your worksheet or on your worksheet, remember this is textbook C. Again, we don't have access to this online just yet because this would be summer term work, but we've moved it to online learning because we think it's a bit easier for you to access than problem solving, multiplication and division, which might be a bit of a headache, remote learning. So we've tried to mix up our units slightly. Okay, so I'm just going to go through these independent challenges for you. We've got, similar to yesterday, question 1A is just asking you to circle all of the equilateral triangles. It's just asking you to go back to the start of this lesson and think about what do you know about those triangles. What does equilateral mean? Equal actually is spelled slightly differently, but the word equal is actually in equilateral. So that gives me a massive clue. Equilateral means equal sides. Okay, it needs to have all sides that are equal, all angles that are equal. So can you firstly identify and circle the equilateral triangles? Okay, then question B, same again. This time you're just going to circle the isosceles triangles. Okay, this is just making sure that that knowledge of identifying what is an equilateral, isosceles, and a scalene is going in. So just a reminder that an isosceles are two sides and angles that are the same, one that is different. So isosceles triangles, two angles that are the same, one that is different. And then the scalene triangles in question 1C, all angles and all sides are different measurements. So can you circle all of those? By the time you finish question 1, you should have identified an equilateral, scalene, and an isosceles. Okay, moving on to question 2. Similar to yesterday's, I think it was question 3, you've got a rug here, and you just need to go through and identify those different types of triangles. So this time, difference being here, the progress, you've gone from just identifying one in a group of pictures, just identifying one in a group of pictures, just identifying one. This time, you've got a range of triangles in there. You need to identify all 3. So equilateral need to be coloured in red, isosceles coloured in yellow, scalene coloured in blue. Like I said yesterday, if you don't have those colours to hand, it doesn't really matter as long as you've got 3 different colours and you let me or Miss Nook or Miss Bishton or Miss Bostock know which colour represents what. So equilateral could be black if you like, isosceles could be green. It's entirely up to you as long as we understand the key that you have used instead. Okay, so go through this rug and can you identify the different types of triangle? Okay, I won't be colouring these sheets because it's not a type of triangle. So I'm looking for only triangles to be coloured in, and I want you to locate the equilateral, the isosceles, and the scalene. Okay, then moving on. Question 3 has got this little light bulb in the corner. That means it could be a bit challenging. Okay, so that means the answer might not be as obvious as I think it is. It might mean that I need to do a second step. Okay, I've been given a square. I need to draw 2 lines on my square to create an isosceles triangle and 2 right-angled triangles. What I could do for this, and what might be easier for you to do, is if you get a scrap piece of paper, okay, get a scrap piece of paper for me and turn it into an equal square. Now you can do that by, if I just pause the video here, and I'll go and see if I can get a scrap piece of paper for you. Okay, so what I've done, I've gone and got I'll just move it down so you can see the creases. I've gone and got a piece of paper. In order to make this rectangular piece of paper square, I've folded this corner right down to the bottom edge. Okay, once I've done that, I've got this left over bit. I don't need that bit. So what I'm going to do is I'm going to cut that bit off. Okay? You don't have to do this, but this might help you with this challenge a little bit. So I'm just going to cut that off. Okay? So when I cut it off, I'm actually left with a nice square piece of paper. Okay, and what I can do with that square piece of paper now, before I draw all over this, is I can start to fold it in different ways to see if I can create an isosceles triangle and 2 right-angled triangles. So I just need 2 lines, which means when I'm using my piece of paper, I need to put 2 folds in. So I'm going to ignore this line here because I've already put 1 in. Okay, if I do it that way, I can see that I've got an isosceles triangle because I've got 2 sides and 2 angles the same, but I've got 1 length that is longer than the others, and I've got a right angle here. Okay, so I've got 2 acute angles and 1 right angle. So I've done one where I've made 2 examples of an isosceles. So that could be 1 line. Okay, then I'm going to fold it in a different way to see if I can work out if I can get 2. Another isosceles triangle. So I should have 2 lines drawn on there, but have a go first with the paper if you like. Okay, it might make your life a little bit easier than having to get stressed and rub everything up on here. Okay, and then last but not least, you just need to sort the triangles below into the correct part of the table. So you've got 4 shapes here. Can you decide whether or not they have got 2 or 3 equal angles? or no equal sides. So for example, I'll help you out with this one. So A, it looks like 1, 2, 3. It has 3 equal angles. Okay, and it looks like it's got 3 equal sides. So A, if I can't really draw on this, but A would go in this top corner box because it has got equal sides and equal angles. Okay, and then you just need to sort the other 3 into the boxes. Okay, remember this character here, sometimes they come up to give you a bit of a clue. I wonder if it's possible to have a triangle in every box. That means that there might not be a triangle in every single box. Okay, so just go through. Firstly, has it got the equal angles? Then move across. Has it got equal sides? Okay, and then move across. Okay, and I think that is it, other than this challenge here. Remember, the challenge is there as a challenge. It is not expected for you to go on it if you don't feel comfortable with it. Okay, it might be that you do feel really comfortable and want to have a go. But how many isosceles triangles can you find within this pentagon? Okay, and that is your learning for today. Again, please do send us on a Class Dojo or via a message. If you're stuck with anything, please do let us know, because we can go through and give you some feedback on the lesson, okay, and try and help you out. Right, and that's it for today. I will see you very soon. Bye.